Yeah, take it away.
All right, awesome. Thank you, everybody, for giving me your attention for the next 25 minutes. I really appreciate it. And thanks to Mercury for setting up this event. It's very nice to be back into the meetup groove. So, yeah, my talk is, or in other words, using Monadic DSLs to build web applications. So I'm kind of just going to be going over a sort of interesting way that you can build web applications. And so a bit about me. My name is Rashad. I'm a software developer at Maxis. I think the mic is cutting out every now and then. Is everything okay with audio, or should I just keep going? Okay. Yeah, so I'm a software developer at Masterword Services. Masterword is a translation and interpretation service provider. We use Haskell to build an in-house ERP system. I have been using Haskell pretty much exclusively for the past 4 years. I've been a part of the Haskell community since about 2018. I'm interested in, although I've been using Haskell for pretty much web development most of the time, I am interested in formal methods, type theory, and programming language theory. So if anybody wants to share any ideas or talk about those type of topics, feel free to reach out to me after the talk. And yeah, so the first thing I kind of want to talk about is just the fact that we can use do notation to do many things. So Haskell is very well known for being, the go-to tool for when you want to create a domain-specific language. And as you can see this sort of description on the slide here, I've taken this from a really cool document created by Gabriela Gonzalez, and many people in the Haskell community have contributed to it as well. It's called the State of the Haskell Ecosystem, and it basically gives Haskell a rating in various programming domains. And in this case, for domain-specific languages, which is one of the domains, it has a rating of mature, which is very good. The only reason it doesn't have a best-in-class rating is because of Lisp, obviously, and that's kind of mentioned in this description here. So I'm just going to kind of read it really quickly. It says, Haskell rocks at DSL building. As a Lisp language, I would venture that Haskell is the most flexible of the non-Lisp languages. You can overload a large amount of built-in syntax for your custom DSL. And the main point I want everybody to focus on here is that, the most popular example of overloaded syntax is do notation, which you can overload to work with any type that implements the monad interface. The syntactic sugar for monads in turn led to a huge overabundance of monad tutorials, which I don't think is necessarily a bad thing. I'd rather have more than less. But anyway, so we have a few examples here of, do notation being used to describe, very different ideas here. So this is an example from the Monad Bayes library, which is a library for probabilistic programming. And we have an example of a do notation being used to describe a uniform distribution over two Boolean values, true and false. And this isn't really an interesting example, so I do recommend you check out the Monad Bayes documentation. They have a lot of great examples there, including graphics and stuff like that. So this is an example of using do notation to describe probability. And then over here, we have something that might be a little bit more familiar to the people in the room here. This is an example from Megaparsec. This came from the Megaparsec tutorial by Mark Karpov. And here we're using do notation to describe a parser. And so the main point I'm just trying to make here is that we can use do notation to describe, very different ideas with the same syntax. We're using the same syntax, but as the developer, we can change the semantics. We can change what this notation means, which is really awesome. So moving on, kind of going over some DSLs in relation, because I'm a web developer, we're going to talk about some DSLs that are used in web development and how we can use these to build web applications. So the first one I'm going to quickly go over is Lucid. How many people here are familiar with Lucid by any chance? I'm sure. Okay. So some people. So yeah, Lucid was created by Chris Dunn as an alternative to Blaze HTML. And it takes advantage of the fact that, you know, HTML has this really tree-like nested structure, and it can be really nicely represented using do notation. And it's really straightforward, honestly. If you're familiar with HTML, you have these tag names. So like in this example, this is a table tag, and we can pass it a list of attributes. And if we want to nest more HTML within that tag, we use the do keyword, indent, and then we can create more HTML, and we can repeat that as much as necessary to get the desired HTML structure we want. This is really useful, and I have the block arguments extension turned on, so usually you would need a $sign right here after the list, but because block arguments is turned on, that is no longer necessary. And yeah, I recommend you read Chris Dunn's blog post on Lucid. He kind of goes more into detail about the motivation for Lucid and why it's pretty awesome. The next one I'm going to be going over is Relate. Out of all the DSLs I'm kind of going over, this is the one I'm the least familiar with. But it's really cool. It's fairly new. So this was created by Ollie Charles and his team at Circuit Hub. I believe they've been using it there for a few years now. And it's a great alternative to some of these other SQL libraries that we have in the Haskell ecosystem. So Relate, as you know, the other libraries I mentioned in this talk, it leverages do notation as a way to create like a nice ergonomic API for interfacing with a database. In this case, it's only Postgres. It can only be used with Postgres at the moment. But I have this sort of graphic here. So I asked Ollie Charles for permission. So this is from his talk on Relate, which I highly recommend you watch because he gives a really great overview of Relate and sort of the internal workings of Relate and all the cool stuff you can do with it. I'm only going to be providing like a trivial example of how to use Relate. But there's this spectrum of SQL libraries that we have in the Haskell ecosystem. And so we have some libraries that are pretty much just raw SQL. And these work usually by, you know, using quasi-quotation. You'll just write raw SQL, and that's pretty much it. And I've always been a big fan of these. Like I use PostgreSQL Simple and Haskell very often, just because to me it was simpler most of the time than some of these alternatives in the middle, like Beam, Opali, and Zelda. I'm not really too much familiar with these. But now on this end of the spectrum, closer to a custom DSL, we have Relate. And so it really, it's really nice syntax. It diverges from traditional SQL syntax, and it's closer to Haskell. And so as a Haskell developer, that is very nice. If you want to learn more, I recommend you check out this talk on YouTube for more information. And here I have a kind of small example here. This is from some code that I'm going to be showcasing later on in the talk. But this is a query right here that we're creating. So imagine you have a table of contacts, and we want to query a contact by ID. And so we can use these statements in this do block to do just that. And we have a where clause right here. And right here we want to match the ID. Well, we want to select the rows that have the correct contact ID, and then we return those rows accordingly. So that's that. And here is Okapi. Okapi is a framework that was inspired by micro web frameworks and other programming languages like Giraffe, mostly Giraffe from F#, but also Express and Node.js and Flask from Python. And this is a side project that I've been working on part-time for the past few months. And the main motivation for it was I wanted a simpler alternative to some of the more complicated web frameworks in Haskell. And so this sort of code block right here sort of sums it up nicely. Right here, we're describing a server, once again, using do notation, because Okapi is a monadic DSL, to describe a server that greets the user. And so the user can either go to the greet endpoint followed by a path parameter, including their name, or they can go to the greet endpoint and provide a query parameter named name, or they can just go to the greet endpoint and not provide any additional information. And we have these series of statements right here that parse the HTTP request. So if you're familiar with attoparsec or megaparsec or any other monadic parsing library, you'll be feel right at home with Okapi. It is essentially a monadic parser for HTTP requests. And so we check on the first line that is a GET request. And then on the second line, we're checking that the first path parameter is greet. And on this third line here, we're saying there can either be a path parameter, or this is from the alternative type class, we can have a query parameter named name. And this is an optional piece of data. So, and this optional right here is coming straight from the parser combinators library. So this is also nice because we get some code reuse here. And so that basically turns the result of this parser into a maybe. And so if this parser fails, we get a nothing. But if it succeeds, we'll get a just, and we can continue on. And this is a parser just to make sure that there's no more path segments in the HTTP request. And then here we're using a let expression, and we're creating a response. So if the user didn't provide a name, it'll just say hello there. If they did provide a name, it'll say hello, whatever your name is. And this is built on top of Y, so it can be used with other Y-based frameworks like Servant. And there is an example in the official Okapi documentation of Okapi being used with Servant. So it can be slowly introduced into a code base if you be using Servant or any Y-based web framework. And so, yeah, we're going to be using these three monadic DSLs for full stack web development. So I prepared a small trivial example that I'll briefly be going over, but basically we're going to be using Lucid for generating HTML, Okapi for implementing the server logic, routing, session management, etc. And we're going to be using Relate for interacting with the database. And just to briefly kind of go over the architecture here, because some people may be wondering, okay, what about the front end? And how can we build a interactive web application without using something like React, Elm, PureScript, or GHCJS? And the answer to that question is by using technology called HTMX. So has anybody here heard of HTMX by any chance? Okay, some people here have heard about it. 3 people. So it's kind of interesting. So traditionally, we have like an SPA architecture here where there's a thin server. It's kind of like a dumb JSON server. It doesn't really do much. It's basically just used by the client to provide more JSON, and the client is doing the majority of the work. And so this is kind of a shame because Haskell doesn't really get to shine. It's kind of just relegated to just serving JSON, and we don't get to use a lot of the cool features of Haskell that we like to use. And this is the HTX Architecture. And HTOAS stands for hypermedia as the engine of application state. The roles are sort of reversed. And it's interesting because instead of the server returning JSON, now the server returns HTML to the client. And HTMX, what HTMX does, it swaps HTML into the DOM automatically. So, and that HTML is embedded with HTMX attributes, and those attributes are triggered by the user of the application, and more HTTP requests are sent to the server, and then more HTML is returned to the client, and then we kind of have this sort of cycle right here. And yeah, the client doesn't have to do much. It basically just accepts the user's interactions and makes requests to the server. And you can kind of compare it in a lot of ways to the Elm architecture. So we'll kind of be seeing how this works, but this is an example from the official Elm documentation. This is a graphic that kind of shows what the Elm architecture is. And in the Elm architecture, for those who are familiar with it, we have a message that is triggered by some interaction. That goes to Elm, the Elm runtime, and then you'll use that message, and based on that message, you'll generate HTML that's inserted into the DOM, and then that cycle sort of repeats for each user interaction. With this architecture, the HTOAS architecture, the messages are no longer messages, they're HTTP requests. Well, they're still messages, but they're HTTP requests, and they happen over a network connection. This is sent to a Haskell server, and depending on the request, the Haskell server will respond with HTML, and now we have HTMX added to that, and that cycle sort of repeats based off each user interaction. So let's look at some code. So I have a simple sort of contact book example here, and at this point, feel free to jump in and start asking questions. And I'm just gonna kind of be, walking down and kind of explaining various parts of this application. But if you have any questions, just feel free to jump in and ask. So we can do some things here, like, well, let me see if I'm running this thing first of all. Yes, it seems that I am. So let's say I made a new friend named Larry, and I can add him to my contact book. I can edit these. So let's say Bob changed his email to bob123@gmail. I can save that, and I'm doing all this I haven't used any JavaScript in this project. This is just HTMX attributes and a Haskell server that's returning HTML back to the client. So when I click on this button, for example, when I click on edit, the server is returning a form back to the client, and that's being swapped into the DOM by HTMX automatically. And I can cancel this if I don't want to change it. I can cancel that. I can click on delete, and I get a confirmed dialog box, HTMX, and I can click OK here, and Larry is gone. So yeah, that's how that works. I can so now just to kind of walk through the code here. So this is about 500 lines of code, and like I said earlier, feel free to jump in and ask any questions if you have any. Yes, please.
If you have a chance to dive into what HTMX is, and this is totally new to me, so.
Yeah, definitely. Yeah, let me walk through some code and kind of show like how it works. I didn't really explain that at all. I'm sorry about that. So here, the way it works is you have these attributes in your HTML, and these make the HTML elements in the DOM interactive. And so we can trigger various events using these HTMX attributes. So you can trigger certain things to happen. Like for an example, you can trigger let me find, so this is the add button right here. So this is what we saw right here in this bottom row of the table. This triggers an HX post request. It triggers a post request to the given URL when the button is clicked. And so that's essentially how it works. It's an event-based system, and you use it just by adding attributes to your HTML. So if I were to inspect the DOM here really quickly, you'll see, yeah, I have an HX post attribute right here, and HTMX is written in JavaScript, by the way. So the creator of HTMX basically created HTMX so that we don't have to write as much JavaScript. He's basically done all the work for us in a sense. And so, yeah, HTMX sees this, and when an event is triggered, it sends a request to the server to this URL right here, and the Haskell server is going to respond accordingly. And so that's how that works. And yeah, just to kind of go through some more code. Well, I won't go through much anymore. Yeah, do you have a question? Yeah. I'll just start taking questions.
Does closest TR in that code imply that if it's going to replace the closest table row with the response from?
Exactly. Yeah. So that is a great question. Yeah. So what triggered the event? Whatever triggered the event, table row that trigger will be replaced, yeah, by the response. And so, yeah, I have some examples here. So basically, so these are the functions that I'm using to generate HTML, and these are being returned to the client accordingly based on the request that the server receives. And this is the server here, by the way. So this is the contact server. So I have different endpoints, get contacts, create contacts, so on and so forth. And yeah, we're returning HTML back to the client on each request. Yes. No, so that's the cool thing about HTMX. It doesn't reload the page on these requests. So when I make a request, like, boom, I sent the request, a request from the server, a response from the server is returned, and HTMX swaps it into the DOM without reloading the page, which makes that very nice. And so it gives it this SPA feel, even though it's not really an SPA, it's actually rendered on the server. Yes?
Do you get partial updates for free, or do you have to like key elements, or is it doing partial updates at all? I can't quite tell.
Oh, I'm sorry, what do you mean by partial elements?
So instead of like replacing the entire web page, it's like a subset of it, like kind of like.
Yeah, exactly. Yeah, they're all partial updates. Exactly. Yeah, so I'm just returning part back to the client based on the, and the partials, they'll contain HTMX attributes, and then, so that's the meaning by HTOAS. That's what's meant by HTOAS, is the hypermedia is the engine of application state, because the hypermedia determines the next set of actions that the user can take. And so the server is really doing a lot of the work here, instead of in contrast to a more traditional SPA architecture.
Does Okapi give you any safety in terms of the ordering of the parsing? Like, we know that every request needs, each to be get or post at the beginning. Like, are you going to get a type error if you throw that like in the middle of your parser?
No, that's a great question. You can actually, like as an example here, if I go back to this code block right here, like this method get right here, I could place this afterwards as well, or I could just not have it at all, and this would just accept any type of request. It would accept a get, post, put, whatever we want, but the fact that I have it there, it checks that, yeah, this is indeed a get request. Yeah. that'll fail actually. So if we try and parse the same part of the request twice, similar to, you know, an actual textual parser, like if we had AA, and I try to parse A in 2 times, so 3 times it would fail. Great question.
Is that a compile time or a runtime error?
This is runtime. Yeah. So this Okapi isn't as type safe as, you know, Servant or Yesod, but there is an interesting. If I have some more time, I do kind of want to show this. You know, we can use. There's an interesting way that we get some type safety back, and we can do that by using these bidirectional patterns to describe our roots. So as I was scrolling through this, I don't know if somebody kind of might have seen some of these pattern definitions right here, but we can describe a root as a pair of a method and a list of path segments. And so, yeah, I have various roots right here. And the cool thing about this is patterns can be used to also deconstruct. So we can use these to pattern match on a request, and we can also use these to construct things like URLs or HTMX attributes. So I have like 2 functions here, like 2 URL and 2 HTMX attribute. And I use these right here as an example. So I'm creating an HTX get to the edit contact root. And I'm using this edit contact pattern to both pattern match on the request and create it. So, yeah.
Yes, less of a question, more just like a note. Using the qualified do extension, and like to enable like an indexed monad, you could actually make that a compile time error, I think, by like keeping track of whether you.
Oh, that's awesome. Yeah, I didn't know that at all. And, you know, I'm looking for people to, you know, help me out with this project. It's something I've been working on, as I said, part-time, kind of by myself. I have made a few blog posts on the Haskell subreddit, and it has gotten some interest, but yeah, if people are interested in creating like a simpler alternative to some of these other web frameworks in the Haskell ecosystem, I'd be more than happy to collaborate, and that's like a perfect example right there. I did not know that. That could be something that's very useful and provide some more type safety to Okapi, because with Okapi, it's sort of a more flexible thing. That's kind of the thing I was going for, and yeah, so thank you for that. I'm sorry, did somebody have their hand up over here? Okay. All right. Well, I guess that concludes my talk. Yeah, thank you.